We're going to look at what's called the symmetry of a graph, and a very particular two types of symmetry called even symmetry and odd symmetry. We say that a function has even symmetry if its graph is perfectly symmetrical around or about the y-axis. So in other words, it's like a mirror image of itself across the y-axis. And a function we say has odd symmetry if when we rotate the graph 180 degrees, so like you like twist it clockwise on itself, then so specifically around the origin, the 0, 0 point, then you actually have the exact same graph. So the reason why we look at even and odd symmetry and why they're called that is going to be made a little bit more clear when we look at the algebraic symmetry. So when instead of looking at graphs, we actually look at functions that are explicitly written. And we'll do that very shortly. For right now, we are just going to look at the graphs and use these definitions here. And then we'll see how it ties together in the next lesson. All right, the first one. So what we can see with this one is it's going through the 0, 0 point, and then what we can actually see is, yeah, we get this nice rotation of 180 degrees of all of these points. That is basically exactly what we want for my odd symmetry. So we would say that this one's odd. Right, so that's good. Now for B, it's just a pretty basic parabola. As you know, parabolas do have some kind of symmetry to them, right? They have a symmetry about a particular vertical axis, but that's not quite what we're looking for even and odd symmetry. So it's pretty clear that if I rotate this 180 degrees around the origin, I definitely don't get the same graph, because basically everything that I've drawn here is then going to be in a completely different quadrant. Right? It's in the first quadrant now. It would actually come down here to the third quadrant. So that's not it. We don't have that rotation for sure. It's not odd. And for even, while this is a reflection around some positive axis, it's certainly not a reflection over the y-axis. So we don't have that either, right? That reflection would show up over here, and I don't have that graph. So I don't have either of those, so this will have neither symmetry. Doesn't mean that it has no symmetry at all, but it doesn't have even or odd. So the third one, we can see certainly not a rotation again, because that would put the whole thing on the bottom. But what we can see is all the points are reflected across. Right, if you take this picture and just flip it over itself across that y-axis, we will get the exact same image. So this one will have even symmetry. I don't know why I'm writing symmetry for this. I can just stick with the word even. And then finally, this last one. So this is going to be what a lot of the trigonometric functions are going to look like, something along these lines. And if you look at it, there's certainly a bunch of different reflections that might take place here, right? I could do a reflection across whatever this axis is, or like pretty much anywhere where we get those bumps. I could have a reflection across that and it'll look the exact same, but I don't get that on the y-axis. If I flip it on the y-axis, what's actually going to happen is that maximum is going to go over there where I don't have a point, and that minimum is going to go over to the right where I don't have a point. So that doesn't work. What we could try instead is that rotation. There actually is a perfect rotation. So it's a rotation around whatever that point is. And I would have the exact same graph, but that is not the origin. That's not my 0, 0 point. It's raised a little bit. So I don't really care what that point is, as long as I know that it's not 0, 0. So this also is not going to have either even nor odd symmetry. So you're really just looking for that very specific criteria, a perfect reflection across the y-axis, or that perfect rotation across the origin. So that's basically symmetry across graphs.